What's going on, guys? It's Cal here from KR Sabers, and this is just a brief overview video for some tips and tricks on making your tactile switch that we're going to be releasing very soon. These tactile switches are all in-house. We did toy with the idea of having them produced by an actual switch factory, but I guess one of the main concerns is that the whole design was totally unique. It might have been a bit risky to give the design to a factory without some sort of agreement where it couldn't be sold to anyone else or it couldn't be used for their purposes, because I do think the design is a great design and I spent a lot of time on it. So essentially I designed 3 switches, all in a bit of a similar concept. I've been toying around with different ideas from launching the initial flagship, because a lot of people wanted to have dual support for the first production run of flagships, as I only had one button, before we added on the second run a pilot hole on the rear side for a second button, and then still the demand was there for buttons that had dual support. So it actually started off with just the design for a dual switch like this one here, but this was the dual switch design. I do offer them in 3 different finishes. We'll have aluminium, anodized black and brass to match the flagship finishes. It was mainly just to have a 3-piece system that could be machined and actuator that would press a PCB inside. I've been doing a lot of CAD modeling recently with switch PCBs and figuring things out with the actual PCB design and mechanical design, so it was quite fun to come up with this. As you can see, we've got tactile switch functions there. I've never been a fan of the springiness of 12mm AV switches, and never been a fan of how thick they are, so you can see that these ones are far less tall than traditional AV switches. I've got a traditional AV switch here. You can see for comparison just the size difference. It's about sort of half the size, maybe. You can see on the camera there. Big difference in size. After I designed this concept and finished the PCB design for it, I actually realised that there might be a way, because this is what the PCB design is. I said to myself, there might be a way that I could fit some pixels on here after finishing the designs, and that was when I came up with these ones. I haven't got the brass one here right now because I used it for a build, but this is the aluminium one, you can hear, and the black one. And I realised that I could actually put some pixels on there, and I've also made a dual pixel one, which is like these, you can hear. These are just the samples. I've now got the full batch in, so I'm just showing you on video these samples. You know, these switches are used in a lot of lightsabers, and nothing's really changed with regards to AV switches for a long time in our community. So it was really fun to come up with a solution that kind of is brand new and something that hadn't been seen before, but another way in which it could be kept in-house. So technically these could be made in any materials, whether it's anodized, different colors, brass, steel, aluminium, anything that can be really a machine material. The switches can be designed in. The PCBs are all safe. This is the pixel PCB. You can see we've got 6 pixels on there, and also I really like the tactile feel of them. I'm a big fan. Now it's all a very low profile, small form factor, so I thought maybe I would show you guys in a bit more detail how these work, what to look out for when you're soldering, and so on. So on the single pixel switch, you've got pads at the back. They are all labeled as well. I don't know if you can see there, but I might have to zoom in a little bit further or crop the video eventually. But you've got 6 different pads on this one, which I'll show you now. You've got C, which is the common for the switch, the common ground. For Verso it would be common positive, but for the majority of soundboard it's common ground. You've got G, which is the ground for the pixel. You've got S1, which is the switch pad. You've got D, which is data, and you've got V, which is voltage. So V, D and G are all pixel related. So positive for the pixel, data for the pixel, and ground for the pixel. C is the common ground for the switch, or the common pad for the switch, and S1 for the switch itself. On the dual pixel, it's exactly the same in terms of the naming of it, whereas you've got a secondary switch pad which is called S2. So S1 and S2, S1, S2, those are for the switches. You've got the common for the switches, and then you've got D, G and V for the near pixel. And then the one that is not illuminated is pretty standard. You've just got S1, S2 and C for common. So very small PCBs. Now I want to go over how you should be soldering these, because smaller PCBs and smaller solder pads, there's some important principles that you would need to be aware of whenever you're soldering something that is a thinner PCB than traditional PCB material. So there's a few things that you need to know. These PCBs will get hotter because they're thinner, and the pads have a smaller surface area, so they don't dissipate heat as much. So it's really important that when you're soldering, you're using a very sharp tip, just like this one, and you want to make sure the tip is nice and clean. You want to have your brass sponge or copper sponge, so you make sure that you brush it there. And something that's really useful as well is just some tip tinner. I don't know if any of you guys use tip tinner, but this stuff is really useful. And the best way to clean your soldering iron, every few pads that you're soldering or every project, just when you're done, just hold it on the tip tinner and it cleans it a bit. It's just solder suspended in flux, and you just give it a clean with a brass brush. And making sure your iron is clean is super important for getting good soldering results, so really do keep this in mind. We'll do a pixel switch at first, so I'll put these away. We'll just do the black one. So what you've got is the main housing, you've got a retention ring, and you've got a plunger and a diffuser. So the diffuser is what diffuses the light, you've got the plunger which sits in there, and the housing and a retention ring. So these retention rings have slots in them, so you can remove it. So you would just simply, they come as little kits, so you'll get these parts in a little bag. You've got your threaded retention ring, and you've got your PCB which sits inside. You've got the diffuser ring and the plunger inside. You can glue those in or you can press fit them in, so this is a separate piece. And then you've got the housing, so you'll drop the plunger in there, make sure it's seated flat, just use some sharp tweezers. You put your PCB in when you've done your wires, and you can tighten this ring, and you can dial in the tension of the feedback. So you just, let's see what it's like. Feels pretty good, but I think it can be tightened just a little bit more. Yeah, that seems good. And if you want, you can put a bit of Loctite on the threads so that no vibrations, or when you're screwing it in, it doesn't unscrew. So that's really important. When it comes to soldering these, I'll show you how to solder it. I'll do a little demo. So it's unscrew this. You can take the whole housing apart. I want to get my vise just to hold the PCB in place. And we've got 6 pads. What we want to start off doing is we want to start off tinning all of the pads. So get this nice and tight there. And for this demonstration, I'm just going to solder the NeoPixel pads themselves, because I've got a little 3-pin connector here, because I want to show it to you when it's illuminated. So I've got my wires already stripped and tinned. I'm going to get my soldering iron, make sure it's nice and clean, and I'm going to put some flux on the pads. I use, if you guys know from my old tutorial videos, I use Fry's Power Flux. Not sure if you can get it in the States, but I think it's pretty popular here in England. I'm just going to put some flux on those pads, and as always, you want to clean your flux off when you've done soldering. I'm just going to get some solder, and we're going to just, not for too long, we're just going to light touches. You don't want to hold the iron on for too long. I'm soldering at about 360. I could say probably bump up to 375 maybe. And this is 375C. I'll just bump up a little bit. So very light touches. And you see now all 6 pads are tinned. Now I'm going to put some flux on the end of my wires. And just to get some really clean results, I'm going to put some flux just on the pads as well once more. I don't need any more solder because I've already tinned the pads nicely. So for data is yellow in my scenario, so I'm just going to... So data's connected, red is the voltage, that's connected. You see I'm just doing it very briefly, and the G is for the ground. So we've got all three connected now, and as always I want to get a toothbrush, a little bit of contact cleaner, and just give that a little brush, get any excess flux off there. Yeah, everything seems okay. I'm just going to bend the wires so that they're coming down. So like I said, they're the kind of passes that you want to be doing, just light passes, not too hot. Don't hold your iron on for too long and you'll be absolutely fine. The pads will remain nicely intact and not heat up too much. So then we're going to put the actuator in here, drop that in, put the switch in, get our lock-in ring, didn't grab the threads properly. There we go, make sure that's sitting right. Test the switch. So maybe a little bit looser for a better click. That's a nice click. And now I've got my cable, I've got a little connector here which is just connected to a LED controller. And as you can see, we've got a pixel switch, and so if you have a look, I've got my phone and I can just show you guys. If I want red, I can have a red switch. If I want green, if I want blue, white, I can just choose any color I want. And we can have different animations, different colors like this. It's just a bit better if I hold it like that. You guys can see different animations, different styles, pulsing styles, and obviously you can design your Profi code, or you can have it mirror the blade. And because the lights are in a ring, it gives a much nicer effect to the Saber. But this just gives you a bit more customizability for your switches and lets you have a bit more of a fun project. So we've got like blue pulse in there, yellow pulse in, light blue, all different colours, white, and obviously I can turn it on and off if I want to. So guys, I thought that would be a nice little video to show you with regards to these switches for when they launch. They are going to be affordable as well. They're not going to be expensive switches or anything like that. You'll be able to get them in a variety of finishes. The dual switch is a similar system. We've just got two switches that rock back and forth. This is a dual illuminated switch. So you've got a little diffuser that sits in the middle, and if you push this half down, press one button, flip it, you've got the other side, and it has a little light in there. So I hope this video has helped, guys. I hope it's given some sort of information of what to expect when you're soldering them. We are going to do a 16mm version as well, which is easier because it's bigger. I'm really looking forward to seeing how you guys use these and incorporate them into your builds from now, and hopefully this is going to be a bit of a industry change with regards to a lot of the production Sabers out there that use these types of switches. So thanks very much for watching as always. I really appreciate the support, and I'll put all the links below for the switch, and I'll catch you guys in the next video. Peace.